Good morning, one and all. This is Dr. Diana here, and we are going to start with the computer organization. So, I am going to be handling computer organization and architecture paper for you this semester. It's good to connect with you all virtually. We were hoping to meet you all very soon, but looking at the perspectives, I am not sure how long it will take for us to meet you in person. But still, it's a good thing that we can connect online. Now, this computer organization and architecture paper is more like hardware centric than software related paper. But we will still be looking into how the basic computer was designed. And when we try to understand the design and the architecture of a computer, it helps us to make use of that computer more effectively. So, the idea about or the objective of including this subject in your curriculum is that once you understand how a computer is organized inside, it helps you write programs that run more effectively. So, with this idea in mind, we are going to look into the evolution of computer first. I thought it might not be good to start right away with the curriculum. So, this session will be a very small session on what the evolution of the computer is. So, once you understand how this computer evolved, then we will be able to justify why the computer is organized in such a manner. So that will, once we understand the basic organization, then we will be able to differentiate between computer organization and architecture. Usually, when I start the class, I usually start by explaining the terms in the uh, course title. So, what is a computer, what is organization, and what is architecture? That's how I start understanding or giving an introduction to my subject always. But this time, I, sh- I am not sure if you will be able to understand what I say unless you know how the computer has evolved. So, this is going to be an introductory note on how the computer has evolved so that we will be able to understand the difference between the word organization and architecture. Once we go through this evolution process, we will be able to better understand the difference. So, here we move into the evolution of computers. What are computers? Initially, when they started, people were actually the computers. So, computer was originally a job title and not an object or an equipment. So, it was people. It was used to describe human beings or people who actually did certain calculations, repetitive calculations. They were asked to do and submit the results. Some astronomical people, people who are astrologers, who are scientists, all these people used a typing assistant kind of job role called as computer, and their job was to perform repetitive calculations and to give the researchers the result. Now, this is equipment. The first equipment like computer was a counting table. That's the ancient form of a computer. And here you see that these are more like abacus kind of instruments that were used. So from this, only from the counting tables, computer became a equipment. When computer became an equipment, the definition given to the computer was an information processor which takes some input and gives you some output. So that's how people started molding the word computer. And the computer that we know today is this is actually an acronym. They have abbreviated the word computer as commonly operated machine, particularly used for trade, education, and research. So, if you are asked to write what a computer is, then you might have to think about this acronym and expand the word computer into commonly operated machine, particularly used for trade, education, and research, and it processes some data which is given as some input, and it gives you a predictable output. That's what a computer is. Now, this was a very, very long time ago. People started with the use of abacus. Abacus was in 3000 BC. Almost 5000 years back, people have already started using abacus for completing of their calculations. They were beads on rods and they were used to count and calculate. And then they started coming up with Napier's bones. Napier's bones, they were actually uh, they were cuboid like rods, and on the surfaces of these rods were numbers engraved, and these numbers were written in such a way that the entire surface was divided into 8 to 9 rows, and each box in that particular surface was divided using a diagonal line. And certain algorithms were used. You can see the very clear picture of Napier's bones here. So this has 9 rows, 10 rows in every bone on every surface, and each of the bone is divided into two halves using a diagonal. So you can see two numbers in every cube in the surface. Now, using certain algorithms and certain steps, they just used to place the required rods close by and see what is the product of two numbers and all that. That's how Napier's bones was used. So they used the bone structure to calculate faster. And then people came up with something called a slide rule. Slide rule was based on Napier's algorithms. This is the slide rule. So if you can see, people started moving in the slide roller up and down as required to calculate some products, addition, subtraction and all that. This is called as the Jacquard's loom. This Jacquard loom, it started storing programs in metal cards. If you can see the front of it, there are 4 cards that are placed on the loom. So it will take those as input and it will read those cards and find out what numbers are given as input. So this was the first computer that was manufactured, and to your surprise, it is still in use today. Then came Charles Babbage. Now if you can look into the gap, this was in 1801. We are in 2020. This Jacquard's loom happened just only 200 years back. But we were using the abacus for past 5000 years. So it usually surprises me how for 5000 years people were not worried about calculations at all, and in the last 200 years people are dying to calculate things. That's so surprising for me. Now in the past 200 years, look at the exponential growth in the power of computing. That's actually surprising. And then comes Charles Babbage. Charles Babbage is actually called the father of modern computers, right? He's actually an English inventor. He taught math. This is the man, and he came up with a machine called the difference engine. This difference engine was proposed in the year 1822, and it's nothing but a huge calculator. It's a special purpose one. It also had some it was used for naval navigation charts. And then he came up with the analytical engine. This analytical engine or the difference engine, you can see a picture of it. This was the difference engine. So it had a lot of rods and things like that, which was used to move around. And once you start punching in some metal cards there, it would take it as a instruction, and then it will calculate some values, and it was accurate to 6 decimal places. This was a machine that was powered by steam. And the person who started programming on this analytical engine was Ada Lovelace. So Ada Lovelace is a woman. She was the first programmer. So you can see a lot of computer science seats being taken up by girls, obviously. So Ada Lovelace was the first programmer who programmed on the analytical engine. This was the one. So if you can have a look at it, they are only rods that are used to move around, and it was powered by steam. Then came the invention of the light bulb and electricity and all that. When things came into picture, then people started using the Edison effect, and they created something called as the diode. A diode is a vacuum tube through which electrons flow. So once they started identifying the power of electricity and its flow, then it came into picture of how this can be used for computing. So they formed the diode using the vacuum tubes, the same diode principle. They designed the first generation electronic computers. This happened in 1941. 1941. Jacquard's loom was in 1801, and after 150 years, you have the vacuum tubes just before our independence. So it's not like it happened long, long ago. These are vacuum tubes. So a computer using the vacuum tubes was designed, called as the Electrical Numerical Integrator and Computer ENIAC, and it had 18,000 vacuum tubes, and the entire room was 30 cross 50 feet. So this entire room is a computer. So one computer is this big, and it weighed almost 330 tons, and it required special programming capability. Now anybody can program, and the new education policy states that programming should be taught from 6th class onwards. Look at where programmers are these days. Then they moved on into UNIVAC. UNIVAC was proposed in 1951. It was the fully electronic digital computer, and it was created by a university. This is also very much surprising. It was not created in any manufacturing lab or research center. It was created in a university just like ours. This was the computer. Grace Hopper. This lady received the Man of the Year award. And when she started writing in a program, moth actually stuck to the switcher, and she was not able to find out why the program was not correctly working. And when she looked back inside the computer, she saw that a moth had stuck on the printed punched cards, which was why the computer was not able to give you the right answer. So that's how they started calling an error a computer bug. So this is the history that goes back to it. And Grace Hopper was the one who found that first bug. And then you have the triode, and then you have the transmitters. So once transmitters came into picture, they started this use of transistor. So now I ask you a question. What was the biggest advance that led to the modern computers? Is it electricity? Is it transistor? Or is it a microchip? The transistor is the one. So this is the first transistor that was built. A silicon, and this was given a Nobel Prize also. So this is the starting point of the second generation of computers. So this is how they integrated circuits. You have a silica sheet, and then you integrate circuits on that, and when you put it in, it becomes a single chip. The third generation systems started using integrated circuits, and then they installed something called as the operating system, and then things started turning cheap. So once that came, this is this is how processors evolved. So you can look at the processor here. These are all old processor. This was the first microchip, which is 4004. This was Intel's first processor. So a microchip is a very large scale integrated circuit, and the 4004 had 2250 transistors into this small space. That's how we drastically improved in 30 years time, because our first generation computer was a 30 cross 50 room with full vacuum tubes in 1941. In just 30 years time, people came up with this microchip. I don't know how our brains evolved that fast in just 30 years. And then the operating system. This was the birth of personal computers. So you don't have to mechanically drive this and that, and then if you just give it a card, it will give you an answer. How modest this was it. So the first generation, if you can see, from vacuum tubes to